We have determined earlier the slope of the tangent line for a specific function. So we have earlier f of x equals x squared minus 3x. This time, we will have a function, no? Not defined explicitly. But we have a function here with this graph. So our goal is to find the slope of this tangent line at the point x equals a. So this is a here, so that's a. Now this point is a, and of course that line has equation x equals a, and it intersects at this point here with your f. So what is the slope of this tangent line? So if we again follow similar procedure as what we have earlier done, we take values either from the left of A or from the right of A. So this time, we just make use of a point from the right of A. So suppose this is B. Okay, so suppose that is B. And this point is B. So this line, that line has coordinate, it has equation x equals B. And it intersects our graph at that point. Okay. So we have 2 points here. Our goal is to find the slope of the tangent line. This one. We follow similar procedure. We make second line connecting the two. So that's a second line. We solve for the slope of the second line, and then we will move point B to A. So we will allow B to be near to A. So if you have these 2 points, A and B, so that's A, and then this is B. What do you think is the coordinate of A? And what do you think is the coordinate of B? So again, A as coordinate, okay, in the x-axis that's A. On the y-axis, no? So that's f of A. And B as coordinate B, f of B. Of course, the slope n can be solved by using the slope form, f of B minus f of A all over B minus A. But if we allow this to be h, equal to h, there is an equation that we can make, or there is a relationship that we can form from that. That is A plus h, that is just equal to B. So we can express B in terms of A and h, where h is the distance between A and B. So we can change this to B, that's AF of A plus h minus f of A. Again, this is A plus h minus A. Or you simplify it as, okay, that's slope of AB. So that is just f of A plus h minus f of A all over h. So that is the slope of the line AB. Okay, it's the slope of the line AB. Again, if we make our h positively small, so that second line will become the tangent line. Will eventually become the tangent line. So if we allow h to approach to 0, this is the slope, that is the slope of the second line AB. Now this is the slope of the second line AB. This one. If you make your h small positively, what I mean is as h approaches to 0, as the distance between A and B is very small positively, to approach it to 0, this slope, m the slope of AB becomes, or that will approach to the slope of the tangent line. Slope of the, let me change this. Slope of the tangent line, the orange line. This is the slope of the tangent line. The slope of the second line, AB. If you wait or if you allow your edge to approach 0, the slope of the second line, AB, will become the slope of the tangent line. So, mathematically, we may write this one here as slope that we define it as, let's say, f prime at A. This is just, you have here f. This is the slope of the tangent line. You just make it approach to 0. So that is limit of that expression f of A plus x minus f of A all over h, if we allow our h to be approaching to 0. So the slope of the tangent line will be denoted as f prime of A. So this is the slope of the tangent line at the point A. Okay? And we call it the derivative. This is also called the derivative of the function f at A. So what is the relationship between the slope of the tangent line at A and the derivative of the function at A? Yeah, they are just the same. The derivative of the function at A is actually the slope of the tangent line at A of f. So let us make use of this definition, derivative of the function at A. So this is a very important relationship.